Historically, businesses ran on single-function software, known as stovepipe systems. Accounting had its software, HR had another, and marketing had a third. These isolated systems created massive data redundancy and inconsistencies. When departments cannot communicate natively, operations slow down to match the speed of manual data entry. To solve this, organizations abandoned these isolated pillars. Disparate functions are now fused into a single, highly efficient network hub, where data is shared everywhere. This architecture is known as an Enterprise Resource Planning System, or ERP. An ERP links financial accounting, supply chain management, human resources, and all other non-financial subsystems into one comprehensive enterprise-wide view. Organizations use enterprise performance management software to link this data to their strategic execution. But to leverage that capability, professionals have to understand the architecture of the underlying accounting information system, the strict rules of the data lifecycle, and the COSO controls that govern the entire network. In this environment, the accountant's responsibility shifts from simply reporting on the past to designing the structural controls that capture and protect data in real time. We start at the absolute bedrock of this network, the database management system. Data here is organized conceptually. The smallest unit is an individual data item, like a customer name or an invoice amount. This is called a field or a column. When you group related fields together, say the date, amount, and customer for one specific sale, you create a record or a row. Stack all of those individual sales records together, and you get a complete file or a table. But the true power of a relational database lies in how these separate tables interact. Every record in a table contains a specific field or group of fields designated as the key. This key uniquely identifies the record and allows separate tables to be joined based on common fields, entirely avoiding the need for high overhead pointers or linked lists. To manage and extract insights from the structure, organizations use structured query language, or SQL. SQL allows users to execute complex searches, like finding all parts ordered by a specific customer, directly across the joined tables. While active transactions run through this operational database, historical information from across the entire organization is periodically copied into a data warehouse. This separate, read-only repository is maintained specifically for advanced data mining and decision-making analysis. By separating data into distinct tables and linking them with unique keys, a relational database mathematically scales massive amounts of enterprise information, eliminating catastrophic redundancy. Databases store the information, but the business logic engine that actively processes it is the Accounting Information System, or AIS. This diagram depicts the organizational value chain. Information technology, including the AIS, is categorized here as a support activity. It does not directly manufacture the final product. Instead, it facilitates the efficient execution of the primary activities that do. The AIS itself relies on three components. The first is the transaction processing system. This handles the high-volume, routine events necessary to conduct daily business, ensuring each transaction succeeds or fails as a complete, secure unit. The second component is the general ledger and financial reporting system. This focuses entirely on external parties, taking transaction data and producing formal financial statements in strict conformity with GAAP. The third component is the management reporting system. This aggregates data from the cost accounting system to produce internal reports, like budgets and cost-volume profit analyses, specifically designed for internal decision-making. Continuously feeding this three-part engine are the organization's 6 core accounting cycles: revenue, expenditures, production, human resources, financing, and property, plant, and equipment. The AIS acts as the critical translation layer. It intakes the daily friction of raw materials, labor hours, and sales, and converts it into quantified, actionable financial strategy. An accounting information system yields high-quality financial data, but its utility is heavily restricted if it remains isolated from the rest of the enterprise. An ERP system integrates enterprise-wide information by creating one system linked to all of the entity's applications, breaking down functional silos. This diagram illustrates the ERP architecture.
Accounting and finance are directly linked to operational nodes like logistics, marketing, and human resources. They all share a single central core. Because subsystems share data and coordinate their activities, data is entered only once. This breaks down functional silos and provides management with total, real-time visibility across the entire organization. Developing an ERP requires a massive investment of time and capital. The software is extremely complex to customize, and adopting system upgrades often results in significant technical bugs. However, the most difficult hurdle in an ERP implementation is not the technical coding. It is overcoming resistance from employees who must abandon deeply ingrained habits and adapt to a strict single enterprise standard. A massive ERP cannot function if the information flowing through it is unverified, corrupted, or legally non-compliant. This necessitates strict data governance, the process of ensuring the availability, integrity, and security of an organization's data. This wheel maps the data lifecycle. It continuously moves through 7 phases. It begins with data capture, bringing information in, and data maintenance for cleansing. Next, data synthesis extracts insights, leading to data usage. Finally, disposition includes data publication, archival, and permanent data purging. Managing this lifecycle requires a formal record retention policy. Organizations must balance the legal necessity of keeping certain records, like tax documents, for mandated minimum periods, against the extreme financial cost of managing data bloat and navigating massive discovery requests during litigation. Rigorous data governance transforms raw, chaotic information into a reliable, legally defensible corporate asset. By integrating all financial and operational data into a perfectly centralized ERP and database, an organization inherently creates a massive, highly valuable target. This system faces 2 distinct vectors of attack: external cyber attacks aiming to steal or destroy hardware and networks, and internal threats where management might intentionally override controls to commit financial fraud. Standard IT security tools like antivirus software and firewalls are required, but they are insufficient on their own. The system demands a comprehensive architectural blueprint to govern human behavior and operational control. The most comprehensive indicator of an information system's compliance is the absolute control it exerts over the data within it. The globally accepted solution for establishing this control is the COSO Internal Control Integrated Framework. This COSO model perfectly aligns objectives, components, and structure. The top face displays 3 objectives: operations, reporting, and compliance. The front relies on 5 components: control environment, risk assessment, control activities, information and communication, and monitoring. All must be present and functioning to reduce risk. Internal control can only provide reasonable assurance, not absolute guarantees. Human judgment is inherently fallible, and even the most advanced automated controls can be circumvented if employees decide to collude. The modern financial professional manages the entire enterprise data ecosystem, acting as its primary architect, analyst, and guardian.